So I told you that this idea of classifying matter, that it's one that you might do in your sleep at some point. So all matter is made up of atoms. It has mass and occupies space. Matter can be a pure substance or a mixture. If it's a pure substance, it's either an element or compound. If it's a mixture, it can be either a homogeneous or heterogeneous mixture. So now I actually want to add on to that. I'm going to take a few slides to talk about these two different broad types of compounds. And we'll talk about these two types of compounds later on in the course, but I just kind of want to introduce you to the idea. Compounds, we said, are actually atoms that we have the same repeating unit without the pure the atoms that are stuck together chemically and create either a molecule or a formula unit, that same repeating unit throughout the substance. That's what makes it pure substance. We use chemical formulas to represent the compounds. Well, compounds can either be molecular compounds or ionic compounds. And like I said, we're going to talk about this later on in the course, but molecular compounds, we call these molecules, and ionic compounds, we call that repeating unit a formula unit. So I just want to briefly kind of talk about these two types of compounds and what makes them different. So these are actually examples. We're going to pick on molecular compounds first. A synonym for molecular compound is a covalent compound. Now this actually is, here we have our carbon atom. This is methane. And here we have our hydrogen, 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 hydrogen. And you can see the stick right here. Okay, that is the chemical bond that is connecting that central carbon atom and those four hydrogen atoms. We'll be talking more about chemical bonds later. Chemical bonds connect atoms together to make a molecule or a formula unit. Here we have ammonia. So we have a central nitrogen atom, hydrogen, hydrogen, hydrogen. And these actually are lone pair electrons. So those dots, those electrons up there, are actually what helps give this shape, what we call this pyramidal shape to the ammonia molecule. Down here we have our favorite, something near and dear to our hearts. We have a central oxygen atom and two hydrogens. This is H2O. And remember I said that we'll talk about why actually we kind of make this Mickey Mouse sort of shape. This is what we call a bent molecule. And it has again to do with actually two pairs of lone pair electrons that actually kind of scoot those hydrogens down and make them into that bent shape for a water molecule. But these are all examples of molecular compounds. So the thing in each one of those molecules that I showed you is we knew which atoms belong to who. So a water molecule, for instance, is three atoms that are stuck together. We know it has a central or middle oxygen and two hydrogens. We got that, right? Well, I'm going to kind of contrast that with the other type of compound coming up. So here we see our little Mickey Mouse molecules. Okay, so these are water molecules, and now you know a little bit why they kind of have the hydrogens kind of do that, because there's our two lone pair electrons that kind of scoot them and make that happen. So we have oxygen, hydrogen, hydrogen. So you know, for instance, that this oxygen goes with these two hydrogens, this oxygen goes with these two hydrogens, etc. Okay. So now ionic compounds are also written with formulas. A good example of an ionic compound, something we probably use too much of, is NaCl. Now if I were to ask you what that is, a lot of times people would tell me sodium chloride. That actually is table salt, and you are right. That's good old-fashioned table salt. And that's an example of an ionic compound. Okay. In fact, I'm going to go ahead and, if this plays, show you
when
this
sodium and chlorine react, the sodium transfers an electron to the chlorine, forming oppositely charged ions. Although the compound has no net charge, its component ions of opposite charge attract each other to form ionic bonds. In turn, these ions are attracted to others, and an ionic solid called a crystal lattice is created.
Now there was a lot there, and again we're going to kind of come back to this later on in the course, but I wanted to get you, they look more complicated, don't they? Ionic compounds. So just good old-fashioned table salt, when it's in its solid state, it has that what we call a solid crystalline lattice structure. Let's see if I can. Oh, I can't. I'll pull it up on this one. Another example of an ionic compound is this potassium bromide, I think it is.
A crystal of potassium bromide has a distinctive shape with perpendicular edges. This shape directly reflects the arrangement of the ions in the crystal lattice. The compound is composed of alternating potassium ions and bromide ions.
Okay, so before I leave this, I want to show you, and I say it's complicated, but it's not really that complicated. Let's see, let me pick which color. I'll go with green maybe. So you see these, the red and the green, okay? This is in its solid state, and the point here is that what if you were to pick on any red, for instance, those are the bromide ions. It is actually connected to 6 other greens. I think that's right. So you don't know, for instance, if it goes with this one, if it goes with this one, if it goes with this one, okay? Okay, it's like it's a commune, all right? So that's kind of how that works. So ionic compounds. This is just a figure of what a table salt would look like. And again, you see kind of the alternating colors. They actually, in this case, represent Cl. This is my Cl. This is my Na. Now, Cl, Na. We're going to talk more about this, but the Cl actually picks up an electron, becomes negatively charged, and the sodium gives up an electron, becomes positively charged. And it's actually that, it's kind of a stepwise process, that allows for this chemical bond to be formed between the negatively charged chlorine and the positively charged sodium. But I just kind of want you to get a sense for, this is an example of an ionic compound. So, like I said, if we pick on sodium chloride as an ionic compound, any single sodium is attached to what this says 6 chlorine or chloride ions. And so it's not specific for a particular set. So we'll be talking more about that later. And then we bump up against, dun dun dun, another assignment.